Hey guys, welcome to eMaths. Today we are going to do an STPM question, and I will show you that we can do this question in Form 5. As you can see, this is an STPM question, and obviously you can use polar form to solve this kind of problem, which I will be doing it at the end of the video. But what if this kind of question suddenly pop up in STPM, like what happened in 2019, and they tell you that it's a kebab question? Well, the best thing you can do in STPM is quadratic equation. So you need to somehow make this into a quadratic equation, whether in terms of cos square x or sin square x. I'll show it to you. First, we'll add 2 sin x to both sides. So that we'll have a cos x on left hand side and the 2 plus 2 sin x on right hand side. To get the square terms, we will square both sides. Okay, we'll have a cos square x equals to, expand the bracket, we have a 4 plus 2 times 2 times 2 is add sin x plus with a 4 sin square x. And now we need to express whether in terms of cos square x or sin square x. So we need to use the basic identity. Okay, use sin square x plus cos square x equals to 1. It's easier for us to get rid of cos square x, right? So cos square x will be 1, move this to the other side, minus sin square x. On left hand side it is just 1 minus sin square x equals to 4 plus add sin x plus 4 sin square x. Simplify this, maybe we'll minus 1 from both sides and plus with a sin square x to both sides. Here is a sin square x. Rearrange it, we have 4 plus 1 is 5 sin square x plus with a add sin x. 4 minus 1 is 3 equals to 0. And this is a quadratic equation. To make our life easier, I will let u be sin x, so that this equation will be 5u squared plus with a add u, then plus 3 equals to 0. Factorize it. 5u times u is 5u squared. 3 times 1 is 3. When we cross multiply, we have 3u plus 5u, which will give you add u. So it will be 5u plus 3 times u plus 1 equals to 0. 5u plus 3 equals to 0, or u plus 1 equals to 0. U will be negative 3 over 5. U will be negative 1. This is not the end, yeah? We need to sub back sin x equals to negative 3 over 5. And sin x equals to negative 1. You can solve it now, right? Be very careful when you solve this trigonometric equation, because we have a negative sign in front. Still remember, all science teacher crazy? When the value of sin x is negative, means x will be in quadrant 3 or quadrant 4. We'll have a answer from quadrant 3, quadrant 4, answer from quadrant 3, quadrant 4. Be careful, yeah? So, I will first find the value of arc sine 3 over 5, then add with 1 at t, minus with 360 to get our x. Okay, arc sine of 3 over 5 is 36.x699 degrees. So, x, when it is in quadrant 3, will be 1 at t plus 36.x699, which will be 216.x699 degrees. Okay? When it is in quadrant 4, it will be 360 minus 36.x699, which will be 323.1301. Is it? Yeah, correct. Degree. Okay, then what about this one? When sin x equals to negative 1, we know that the arc sine of 1 is 90 degrees. So, when it is in quadrant 3, x will be 1 at t plus 90, which is 270 degree. When x is in quadrant 4, it will be 360 minus 90, which is still 270. Now we have 3 values of x, and are you sure all of them are the solutions? Because we have cos x and sin x in the equation, so it's very risky for us to determine the positive negative based on this all science teacher crazy. Therefore, it's better for us to sub all the values back into the equation to check our answer. When x equals to 216.8699 degrees, we will get the fourth equation. Therefore, x equals to 216.8699 is not the solution for that equation. When x equals to 323.1301 degrees, we will get the true equation. Therefore, this is a solution. When x equals to 270 degrees, we will get the true equation. Therefore, x equals to 270 is a solution for that equation. The answer will be x equals to 270 degrees and 323.1301 degrees. This is how the graph will look like. 2 solutions only. The method from just now is simple but has its limitation. That's why we need to sub back into the equation to check our answer, right? But actually, there is a method to solve this kind of problem directly, which is using polar form. Okay, I will show it to you. First, we will let the left hand side, which is this cos x minus 2 sin x, be a constant r times, just now we do it in terms of sin square x, so maybe this time I do it in terms of cos x. Okay, cos x plus with some angle, let me be theta. Okay, and this is a compound angle, so we can use the formula cos A plus minus B equals to cos A cos B minus plus sin A sin B. In this case, our A is x and B is theta. Don't forget the r, I will put it outside. We have a cos x cos theta minus sin x sin theta. Then we expand the bracket. Okay, we have a r cos theta times cos x. I write the red color together. Then minus r sin theta sin x. Okay, our left hand side is cos x minus 2 sin x. Okay, now you can compare left hand side with right hand side. The coefficient of cos x on left hand side is actually a 1. The coefficient of cos x on right hand side is r cos theta. So r cos theta equals to 1. This is our equation 1. How about this one? The coefficient of sin x on left hand side is negative 2. On right hand side is negative r sin theta. So negative r sin theta equals to negative 2. R sin theta will be 2. Now we have 2 equations and we just have to solve for r and theta. Okay, so maybe I will try to divide equation 2 by equation 1. We have r sin theta over r cos theta equals to 2 divided by 1. R and r can cancel. Sin theta over cos theta is tangent theta equals to 2. We can solve for theta. Theta will be arctangent of 2, which is 63.4349 degrees. It's better to keep more decimal place when you are in the middle of working, okay? Now we have the value of theta and we just need the value of r. To make our life easier and we don't have to sub this theta back into the equation, I will just use the square of equation 1 plus with the square of equation 2. I will show you why later. Okay, square of equation 1. On left hand side, we will have a r squared times cos square theta. On right hand side, it will be 1 squared. Plus with the square of equation 2, it will be r squared sin square theta plus with a 2 squared. And now you can see it already. Factor out the r squared, we'll have a cos square theta plus sin square theta equals to 1 squared is 1, 2 squared is 4. 1 plus 4 is 5. You see, this part here is the basic identity, which is 1. 1 times r squared is r squared equals to 5. So, take the square root on both sides, we have r equals to square root of 5. Now we have all the information that we need. So, we can say goodbye, my friend. And we solve for this part. Let me write it down for you. R is square root of 5. Then cos x plus theta is 63.4349 degrees equals to 2. I think you can solve it already, right? Okay, so x plus 63.4349 degrees will be 2 divided by square root of 5. Then you take the arc cos of it, which will be approximately 26.565 degrees. We still need all science teacher crazy this time, but this time we are very sure that we will only consider the answer from first quadrant and fourth quadrant because we only have one trigonometric function. So x plus 63.4349 degrees will be 26.565 degrees. We will reject this answer because it's not in the range. Then 360 minus 26.565, which is 333.435 degrees. Now we have one more answer. 360 plus 26.565 for the second cycle. So it will be 386.565 degrees. And now we don't have to consider this already. Minus this 63.4349 from this and this, we have x equals to 270 degrees and x equals to 323.13 degree, which is our answer. Just my personal opinion, sometimes people are complaining that the question is not in the syllabus. But actually, in the exam, when you come down, observe the question carefully, you will find out that you can actually do it using what you have learned. And this is what they call kebab. So that's all for today. If you like e-maths, see you guys in the next video.